Welcome to qnawire.
So looking at the graph, we want to determine what it looks like when we have a faucet that increases in temperature. We turn it on to hot water, and what happens? Well, we know that it starts off as cold. It always starts off as cold, and then it quickly becomes warmer and warmer until it's the hottest temperature possible. So a decent representation of this would be this graph right here. Again, these numbers don't matter as much. We could do 5 or 10, whatever. But what we see is that we start off with a cold value, a cold temperature, if this y-axis is temperature. And then as time goes on along the x-axis, we see it's getting very hot quickly, and then it starts to stabilize. It reaches its maximum temperature because when we turn on a faucet, there's no way it can just keep heating up forever. There is a maximum point. So what that tells us is then if we take the derivative, we see what it looks like. And this derivative is showing us, if we look from 0 to infinity, that we have high temperature, a very high rate of change, rather. This derivative graph shows a high rate of change, a positive rate of change, so a quick increase in temperature. And then as time goes on, it's slower and slower as it increases in temperature to the point where it becomes a minuscule amount of change.